Hi, I'm Jonathan Wien, and this is my instructional video on walking through a reagents and yields problem. But let's first assess the definitions of the terms we'll encounter. The limiting reagent is the reactant that can produce the least amount of products and also limits how much product can be made. The excess reagent is the reactant that results in leftover products after the limiting reactant is used up. The theoretical yield is a calculation of the mass of a product. If everything went right and if the limiting reactant were converted without considering other external factors. The actual yield is the mass of product obtained in a real experiment with possible external factors. The percent yield is the ratio of the actual yield and the theoretical yield. And the actual, oh yeah, okay. And this could be put into a formula as shown on the one on the bottom. So this is the equation we'll be going over. In the balanced equation below, how many grams of potassium cyanide should form if 120 grams of KOH reacts with 30.0 grams of HCN? While doing so, identify the limiting reagent and then the excess reagent and the amount of grams remaining after the limiting reagent is used up. Then find the percent yield of KCN if the actual amount of KCN produced was 71.4 grams in the experiment. So potassium cyanide is KCN, and they gave us the equation, which was balanced, so that is a good start. But this is a lot, so let's focus on finding the limiting reagent for now. So to do this, we need to convert each reactant into the moles of a specific product. The product we have to pick doesn't matter, but since the question focuses on KOH, let's go for that product. To find this, we need the stoichiometry map. And so this is the map. It shows us that's the steps we need to go to from mass to moles, from element to element. The arrows show the information you need. Like mass to moles, you would need the division of the molar mass. Moles to moles, you would need the mole to mole ratio, which you would get the numbers by putting the moles of the reagent you want over the moles of the reagent you have. And to find these moles, you would get the superscripts of the balance equation. And to go from moles to mass, you would multiply by the molar mass. Okay, let's go back to the question. Okay, so as we figured out, we need to convert the mass of each reactant into the moles of KOH. Not KOH, KCN. This is demonstrated by the want and given chart. This means we will have two stoichiometry maps. Since the question only gives us the mass of the reactants, it'll be from mass A to mole A to mole B. Okay, let's write that down relating to the reagents. Okay, as you can see, there's two maps. Let's first do the one on the top. So the first step of our map is to convert the mass of KOH into its moles. We would do this by dividing it by its molar mass, which you would get by adding the molar masses of potassium, oxygen, and hydrogen, which would be around 56.1056 grams. The process would look like this in dimensional analysis. Now we have the moles of KOH, but the next step would be getting the moles of KCN. We would do this by multiplying the equation by the mole to mole ratio using their superscripts in the balanced equation, but since there's only one of each reagent, the balanced mole to mole ratio would just be 1 over 1. Let's do that now. Okay, this would be the finished equation Now we need to plug it into our calculators to find the moles of KCN. Okay, so we should have gotten 2.14 moles of KCN after accounting for significant figures. Now that we have finished the first map, we'll move on to the second. Okay, so now we are dealing with the mass of HCN, and the next step of our map is to convert it to moles. So following the process and knowing the molar mass, which is 27.026 grams, the equation would start like this. But now we need to convert it to the moles of KCN, which needs the mole to mole ratio. By using the process we learned with the subscripts and looking at the balance equation, the equation would be 1 over 1. Okay. And now that we have the full equation, when plugging it in, we would get 1.11 moles of KCN. Now, comparing the moles of the product that we got using the reactants, we can determine the one that produced more is the excess, with the other being the limiting. This would mean that HCN would be the limiting reagent, and KOH would be the excess reagent, answering the second step. Now, we know the limiting reagent. This means that we can find the theoretical yield of the product as it would be derived from the limiting reagent's moles. This will help us on our third step. Our third step was to find the percent yield of KCN if the actual amount of KCN produced was 71.4 grams in the experiment, which that would be the actual yield. This gives us a new want and given chart, and also a new stoichiometry chart. But wait, look under the chart. We have a new given as we found out how much moles KCN would be if derived from the limiting reagent. Now all we need is the mass, which is also shown in the stoichiometry map. Now that we have the full equation already, we can just plug it in. This gives us 72.3 grams of KCN after adjusting for significant figures. This would be our theoretical yield of KCN, and because the question gives us the actual yield, we can solve for the percent yield using the formula we saw in the definitions. Seems simple. Let's plug our numbers in. Okay, now let's calculate this. Great, we got 98.8%. Now we need to find how much excess would be left after doing the reaction. To find what is left, we need to find what is being used. Like what we did before, we need to find this by converting the moles of the limiting into the mass of the excess. So now we make our new wants and given and stoichiometry chart. As you can see, our given is new, but we've calculated it before, just like the molar masses, and because we know the molar ratio of the two is just 1 over 1 because all the reagents have the same superscript of 1, we can now form the whole equation right off the bat. This is what it should look like, so let's plug it into our calculators. Okay, we should have gotten 62.3 grams of KOH after significant figures. Now we can subtract it by how much KOH we have, which is 120 grams. This is what the equation should look like, so let's calculate it. Okay, great. Now we should have gotten 57.7 grams as our solution to the amount of KOH left after our reaction. I think we did it. We have finished the problem. Let's gather our answers. Yep, we have everything we needed. This will conclude the video. Thanks for watching.